Hey, what's good, Algebra 2 peeps? We're going to continue looking at how do we factor and solve quadratics when we don't have 0 on one side of the equal sign. This is our second example. I hope you're taking notes, writing this down, following along. So for our second example, let's say that we're asked to solve factoring. The following problem: 2x squared plus 7x equals not 0, -3. What was the first thing that we needed to do in the last example? We needed to get what on one side? If you said 0, nice job. The question that we have to ask ourselves now is, how can we get 0 on one side of the equal sign? What's the fastest way we could get 0 on one side of the equal sign? The fastest way would be to do the opposite of this -3. The opposite of a -3, think of this as subtracting 3 because of the minus. It would be to add 3 to both sides. Okay, and what I'm going to do on this example, I wish I would have done it on the last one, is I'm going to kind of offset the 3 from everything else that's on the left-hand side, because I don't want to make the mistake of putting this 3 underneath the 2x squared or the 7x, and then I end up adding 2 and 3 together, or 7 and 3 together by doing that, because they're not like terms. The 2 and the 7 both have an x glued to it. The 3 has no x, which means the 3 is not going to be able to combine with anything on this left side. The best we can do on this left-hand side is write things side by side, but we want to do it in standard form, which means we want our highest powered exponent to go first, 2x squared, followed by our next highest exponent, the 7x, because this x has a 1 on it, even though we don't write it. Mathematicians are lazy. We don't like to write 1 if we don't have to. And then plus 3 is going to come at the tail end because it has no x's. So to review, highest power goes first, 2 x's, because of this 2 in the corner, 1x, no x's. And what is this set equal to? What's -3 plus 3? It's a 0. Now that we have 0 on one side, we're just going to do what we've been doing before. We're going to try and factor this thing. And to do that, because it's not naked, we have to multiply front end times back end. Front end times the backbone, as some student likes to call the last piece here. He likes to call it the backbone. I like that. I'm going to start calling it the backbone too, I think. Okay, 2 times 3 is 6. We're going to need two numbers that multiply to 6. But those same two numbers are going to have to add to, what's in the middle? 7. So what two numbers multiply to 6, but those same two numbers add to 7? What do you think? I think it's 1 and 6. Let's see. 1 times 6 checks, because 1 times 6 is 6. 1 plus 6 is 7. I have 7 on the other side. These two sides match. The left side matches the right side. We're in business. Now that we have our magic numbers, or the numbers that make the magic happen, we can now start to factor this thing by doing now table time. And to do table time, I do this, 2 by 2 box. I think somebody referred to this table. It looks like a window. That's another way to think of it. And let's start putting our different pieces of our table. First piece, first box, 2x squared. Last piece, last box, 3. We could write plus 3, but I'm going to leave the plus off since 3 implies it's positive. Now, if it were -3, it would probably be a good idea to include the minus. But if it's positive, I'll leave the part off. And then what are we going to drop into our table here in these two slots? Well, we're going to drop in these two numbers that we found to make that magic happen to get 6 and 7. I drop my 1 in, I drop my 6 in, and it doesn't matter if I would have put the 6 here in the upper right and the 1 in the bottom left. It makes no difference in the end. You're still going to end up with the same factored form. Now to each of these numbers, the 1 and the 6, I'm going to glue the letter to it, the variable that we're using, and the variable that we're using is x. All right, now let's start factoring out our GCFs. All right, in the last couple of examples that we've done in class together, I've shown you guys how you can find the GCF if finding the GCF is hard. If you can't look at 2 and 1 and say, oh, the GCF is 1, then what you can do is fall back onto listing out the factors. Hey, come on, quit tweaking on me. You can list all the factors of these 4 numbers. I'll do it really small on the side here. 2 and 1, the factors are 1 and 2. 1, well, I mean, 1 is 1 times 1. 6, we would have 1 and 6, 2 and 3, and then 3, we would have 1 and 3. So do you see what I did there? The 2 and the 1 I get from the numbers in front of the x. Here in the bottom, I get 6 and 3, because those are the numbers that are inside the box. Then I'm just listing all the ways to multiply using whole numbers to get that particular number I'm looking at. If the number inside is negative, if this would have been a -6, I would have ignored the minus and still concerned myself with just the 6 itself. The minus we can take care of separately, so don't worry about that when you're listing out factors. All right, what is the GCF of 2 and 1? Well, if we look at our handy dandy charts over here, I almost said dandelion, we see that the biggest number in both of these charts is 1. GCF of 2 and 1 is 1, and then to determine how many x's to take out, we go with the smaller exponent. 1 is smaller than 2, so we can take out a single x. What's the GCF of our bottom row? 6 and 3. The biggest number in these 2 charts is 3. All right, we can take out a 3. Now we need to determine the sign of this number. We take the sign directly to the right of us. The 6 is positive, so that means our GCF is going to be positive. Now let's look at our columns. What's the GCF of 2 and 6? Well, the biggest number in both of our charts here for 2 and 6 is 2. I'll use that triangle to distinguish between what I did for the rows and what I did for the columns. We can take out a 2. And then what's the GCF of 1 and 3? Well, it's 1. Oh, and by the way, we can still take an x out in the first column also. I almost forgot to do that. Now, to determine this last piece's sign, we look at the box directly underneath us. What's the sign of this box? What kind of 1 is that? It's positive. So we're going to put a plus on our 1. Now what we get along the top and along the left of our window here, or our table, is how original problem here, well actually it's here, right here, when we got 0 on one side, how this guy right here factors. And it factors as 2x plus 1 followed by x plus 3. They're going to be written in parentheses side by side. You see, I really would like to scroll down. Let me go to the computer really quick. I'm sorry about this. This thing is really acting weird today. So let me extend the page a bit. Perfect. Okay, that's what we need. Get a little bit more room up there. Alright, so we have this factoring as 2x plus 1 and x plus 3. You could write the 1 in front of the x, but it's really not needed there. It goes back to what I was saying before. Mathematicians are lazy. We don't like to write 1 if we don't have to. And what we're going to do now is set each of these pieces that are inside parentheses equal to 0. Actually, let me do a little bit of color here. Okay, we're going to set 2x plus 1 equal to 0 and solve that baby equation. We're going to set x plus 3 equal to 0 and solve that baby equation. So why don't you guys take a minute and do that. Pause the video, actually solve those two equations on your own, and then check to see if you got the same thing I did. I'm serious. Pause the video right now. Pause it. I can see you. Pause it. Just kidding. I can't really see you. That'd be creepy, right? Okay, anyway, hopefully you paused the video and tried to solve it on your own. The first solution we're going to get is -1/2 because we're going to subtract 1 from both sides and then divide both sides by 2. The second solution we get is a -3 by subtracting 3 from both sides. It's a marvelous, is it not? It's marvelous. X equals -1/2, x equals -3. Those are the two solutions to our original equation. This first one that we were given, the solutions to it are x equals -1/2, x equals -3. All right, guys, good job. Appreciate you taking the time to watch these videos. I hope this gave you a better understanding of how to solve quadratics by factoring. Keep up the good work. Adios.